Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. First of all, let me introduce myself. My name is Shahnaz Adibah Handoko. I'm a civil engineering student of Diponegoro University. My student ID number is 210101191400178 from Building Information Modeling Class A. So today I would like to present you my presentation about BIM for subcontractor and fabricator. This presentation consists of a section. The first is introduction of BIM. The second is overview of subcontractor and fabricator. Third, the benefits. Fourth, BIM-enabled process change. Fifth, generic BIM system requirements for fabricators. Six, major classes of fabricators and their specific needs. Seven, methodology. And last is conclusion. We go to the first section is introduction of BIM. What is BIM? Building Information Modeling or BIM is a method or stage of using technology developed in the field of AEC or architecture, engineering, and construction, which simulates all information in a development project into a 3D model from physical to functional attributes. The BIM concept envisioned virtual construction before the actual physical construction to reduce uncertainty, improve safety, solve problems, and analyze potential impacts. It is the objective of BIM in according to Smith Tech 2007. Here is the regulation of BIM. Regulation of the Minister of Public Works and Public Housing of the Republic of Indonesia, number 22 PRTM 2018, concerning the construction of state building, which requires the use of BIM for non-simple state buildings with an area of over 2,000 square meters and above 2 stories. Second section is overview of subcontractor and fabricator. Before we discuss it further, I will tell you who subcontractor is. So, subcontractor is an individual or entrepreneur who signs a contract and is usually hired or employed by a general contractor or main contractor to carry out certain tasks as a part of the whole project. And who is fabricator? Fabricator is a company that is engaged in the production of construction materials or building something in various ways, either manually or automated. Here are the types of subcontractors and fabricators that are identified by the type of components they fabricate. First is made-to-stock components, such as standard plumbing fixtures, pipe, drywall panels, and other similar items. Second is made-to-order components, like preset Handoko planks, doors, windows that can be chosen from catalogs. Third is engineered to order components that are customized, such as structural steel frame, precast concrete pieces, custom kitchens, and others. And for classification of building components in more detail is divided into three. First is engineered to order components or ETO. ETO manufacturers typically produce components that need to be designed and engineered. In most cases, ETO producers are subcontractors of the main contractor and or owner. Subcontractor typically cover product design, engineering, fabrication, and installation. The second is design service providers, offers engineering service to fabricate custom design components. Design service providers or DSPs typically perform work on a fee basis and don't participate in fabricating and installing the components they design. Design service providers include structural steel detailers, precast concrete design, and others. And the last is specialist coordinators. The specialist coordinator provides comprehensive ETO product provisioning services by bringing designers, material suppliers, and fabricators together under a virtual subcontracting company. The third section is the benefits of a BIM process for subcontractor and fabricator. The first benefit is marketing and tendering. For engineers, BIM can developing multiple alternatives and then providing reasonable details on solution and measuring quantities. And for marketing, BIM is not limited to its ability to present a 3D representation of a proposed building design and also able to adapt and change parametrically and better use embedded engineering knowledge. The second benefit is shortened production cycles. BIM platform usage can change math into shop drawing and models can be automatically updated. In the full production system, the creation of shop drawing is produced once a majority of change have already been made, and shorten the length of the design process to the point that additional components with longer lead times can be prefabricated earlier. The third benefit is reduced design coordination error. BIM system has the ability to create integrated models of potentially conflicting systems at production detail level, especially interest to fabricators. The fourth benefit is lower engineering and detailing costs. BIM's use reducing costs by utilizing automated design and analysis software more often, and an almost entirely automated production of drawings and manual takeoffs, and the last week is reduced rework due to enhanced quality control and design coordination. BIM platform able to perform the pre-processing of data for analysis software of various kinds. And BIM also allow designers to adopt and top-down design development approach in which the software propagates the geometric implication of high-level design decision to its constituent parts. And the fifth benefit is increased use of automated manufacturing technologies. BIM platform model every part of a building using meaningful and commutable objects. Since the development made in BIM are limited to certain sectors, providing information from which the data forms required for controlling automated machinery can be extracted with relative ease. BIM platform calculate job requirements utilizing automated machine without having to try them. And then BIM also provide the logistical information needed for managing the fabrication processes. And the sixth benefit is increased pre-assembly and prefabrication. BIM platforms enable the companies to prefabricate a greater variety of components for any building project on an economical basis. All design and layouts can be modeled in 3D without having to conceive the details once the components are put into place and can be reviewed together. And the seventh benefit is quality control, supply chain management, and lifecycle maintenance. BIM platform plays a role in monitoring the production process, storage, delivery to the installation site, and serves as the component quality control which can be performed using advanced computer-readable software like GPS and RFID. And BIM also provide lifecycle information on components and their performances that is also supported by the software. The first section is BIM-enabled process change. The use of BIM in the construction sector certainly provide change or their impacts, including one is efficient construction. The impact of utilizing BIM includes the use of resources that can be minimized, such as human resources and materials and equipment resources. BIM facilitates the efficient construction process, which directly impacts on how fabricators and subcontractors work in some ways, namely, first, prefabricated and pre-assembled levels with error-free design. Second, various models are not only useful for identification of design error, but can also be used for exploration of construction sequences. Third, serve enhanced teamwork in coordinating activities across different fields. Fourth, faster construction times since job working can be purchased faster, reducing the time required for actual fabrication and delivery. And impact Number two is less paper in construction. The need for paper report is significantly reduced as information from BIM fabrication models begins to drive logistic, accounting, and other management information systems and is aided by automated data collection technologies. And the last is increased distribution of work. BIM facilitates increased outsourcing and even globalization of two aspects of construction work that were previously the domain of local subcontractor and fabricators. BIM enables for design, analysis, and engineering to be carried out more easily by geographically and organizationally dispersed groups. The fifth section is generic BIM system requirement for fabricators. There are several requirements for the BIM system to support fabrication, including 1. Parametric and customizable parts and relationship. The fabricator must have a software system that supports parametric objects and manage the relationship between objects at all levels. For instance, the use of structural steel connection. The software will select and apply the appropriate connection according to the predefined rules. 2. Reporting components for fabrication. Fabricators of all kind must be able to automatically generate production reports for each ETO component in a building. Reporting may involve tasks such as shop drawing, compiling CNC machinery instruction, listing constituent parts and materials for procurement, specifying surface finish treatments and materials, and listing hardware required for installation on site and so forth. 3. Interface to management information system. This should ideally be an online database link rather than a simple export or import exchange on a file. The software should, at the very least, offer an API so that companies with access to programming capability can adapt data exchange to the requirement of their existing enterprise system. Automated tracking system for ETO components from production to storage, delivery, construction, and operation become feasible if building models are integrated with other management systems. 4. Interoperability. It is essential to have the ability to import and export models utilizing industry exchange standards and the ability to communicate information between the BIM platform and designers, general contractors, and fabricators. 5. Information visualization. Particularly for erectors and general contractor staff outside the fabricator organization, a 3D building model view is a very effective platform for entering and visualizing management information. 6. Automation of fabrication tasks. Some businesses might already have a variety of CNC equipment, including rubber bending and cutting machines, laser cutters for steel purpose or plates, or sophisticated conveyor and casting system for precast concrete. These technologies could encourage fabricators to adopt it. The sixth is major classes of fabricators and their specific needs. The first class is steel structural. It is insufficient to just model the structure in 3D and all of its components, including the nuts, bolts, flats, and so on. There are a number of requirements that must be met, including 1. Automated and customizable detailing of steel connection. This feature must incorporate the ability to define rule sets that control how connection types are chosen and parametrically adapted to particular structural situation. 2. Built-in structural analysis capabilities. The minimal software can describe and export structural models, including loads defined in a format that can be read by other structural analysis software. 3. Capable of providing the output of cutting, welding, and drilling instruction directly to computer numerically controlled or CNC machinery. The second class is precast concrete. because concrete modeling is more complex than structural steel modeling, since it has internal parts such as rebar, precast strands, steel embeds, complex shape variation, and others. Firstly, the ability to model pieces in a construction model with geometric shapes that differ from those reported in shop drawings. Second, the software must support the documentation of volumes required of each type of concrete. Third, required to perform specialized structural analysis of individual parts to check their resistance forces applied during stripping, lifting, storage, transportation, and erection. Fourth, the constituent parts of a precast piece must be grouped in accordance with the timing of their insertion. Fifth, output of rebar shapes in formats compatible with fabrication control software and automated bending and cutting machines. And the third class is cast in place reinforced concrete. Its internal bus must be modeled in details like in the precast concrete and steel structures. Because the IP concrete doesn't have clear physical boundaries between components, such as column and beams and slabs, it is necessary to have clear parameters from software, such as Revit, with its joint geometric features. In addition, BIM software must support multi-view capabilities to model objects. And the fourth class is mechanical, electrical, and plumbing. There are three ETO components included in this category: ducts and machinery for HVAC system, piping runs for liquid and gas supply and disposal, and routing trays and control boxes for electrical and communication system. And for this system to be supported by BIM, their placement, orientation, and route in space must be carefully coordinated. Routing requires visualization, such as using color codes to identify clashes between systems. And then, by grouping of items is made for production and installation logistic. Numbering or labeling must be done on each unique part, installation role, and production group or groups based on identical or similar process. We go to the seventh section is adopting BIM in a fabrication operation. The following are steps to adopt BIM. First is train engineering staff to use the software. Second is prepare custom component guides, standard connections, design rules, and so forth. Third, customize the software to provide drawing plates and reports according to company requirements. Fourth, conduct seminar and or workshops. After the debriefing has been carried out for the individuals or stakeholders involved, the next step is to plan the change where targeted at the stakeholders who have been involved and received the briefing. In the final stage, consideration related to human resources are carried out. Human resources involved in using BIM must have expertise and experience in fabrication organization because they are directly involved in making conceptual design and production methods decision. And last but not least, the last section is conclusion. So we can conclude that building information modeling or BIM can provide a realistic visualization of the building to be built, along with all the information included in it before it is actually implemented in the field. BIM supports the entire collaborative process for fabricators and subcontractors, including design development, detailing, and integration. The benefits of BIM to subcontractors and fabricators include marketing and rendering, reduce cycle times for design and production, minimize design errors, reduce engineering and detailing costs, and increase pre-assembly and prefabrication. In order to successfully introduce BIM into the fabrication plan, it requires familiarization with its own internal engineering stuff, starting with setting clear and achievable goals with measurable achievement. Okay, that's all from me. Thank you so much for your attention. I would like to apologize if there is a mistake. Hope you guys have a great day. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.